Here is a problem. Suppose we have a set of points, and I told you I want you to find the smallest convex set that contain all the points. That means if we have these points, I want you to find the smallest convex set that have all the points inside them. One method of tackling this problem is an algorithm that's called Graham scan. And the way it works is by having a set Q that contains all our points and the stack S that contains the convex Hull set. And the way we construct our set Q is by choosing a point, our initial point, to be the lowest point out of our set. So in this example, we already marked it as P0. So this gives us the guarantee that our point is part of the convex hull, because there's no other points lower than it. Then we sort our set of points based on our initial point by measuring the angle of all the other points in relation to our initial point. This helps us sort the algorithm, give us a method of sorting our, not algorithm, our set, so we can scan through all the points. Now that we have our set, we go to our stack. Since we already said and mentioned that P0 is part of the convex hull, we just push it on the stack. Remember, the stack contains all the set of points in the convex hull. I changed the previous example to make it simpler. So we now push the second item, the second point in our set to our stack, P1. And then we push the other point, P2, to the stack in the set. Now we have an angle between P0, P1, and P2. Okay, and this is important because we will check this angle to see whether it's turning counterclockwise, clockwise, or counterclockwise. Okay, in this case it's counterclockwise, so we continue. We push P3 to the stack, P3. And as we see, the smallest angle is now clockwise. And this where the Graham scan kicks in. We will pop the last two, which is P3 and P2. P3 and P2. As you can see, we popped P2 and P3 from our stack, and then we check the one next to the next. So we check P2, now we check P3 next to the next of P1. So over here it's P3. And we check the angle, and it's counterclockwise, so it's pushed. Now that's it. We gone through the whole set. These 3 points are part of the convex hull, and P2 is not. And to make sure we understand it well, a harder problem. As you can see, we have our set over here, which has already been sorted for us, and we have our stack. I added the P0 over here in the set because I forgot to add it. Okay, so we have our points and we start with P0, we push it to the stack, and then we go to P1, and from our set, we push it to the stack, and then we go to P2. This one is P2. I also made another mistake. So this one is P2, this one is P4, this one is P3. Okay, so we go to P2, we check the angle, so we push P2, we check the angle, it's counterclockwise, we keep it. We go to P3, we check the angle, it is also counterclockwise, so we push it, P3, and we're going through this, through the stack, through the order of, through the set, through the order of the set. Next, we have P4. Go P4, check the angle, counterclockwise. We leave it in the stack. Then we go to P5. And here's where the Garham scan kicks in. In P5, we see it's going clockwise, turning clockwise. So we pop P4 and we go to the one next to the next of P5, to the P3, which is P5. So we popped P4 and then we go P5. We check the angle, it's counterclockwise. We're at the end of our set, and that's Gorham scan. And indeed, these sets make a convex shape that contains all the points in them. And that is how the Garham scan algorithm works to find the convex hull, the minimum convex hull of that contains all the points.